Hello everyone, welcome back to Math 1314, more in math. Today we're going to talk about Chapter 5, Section 5. Section 5 deals with solving exponential and logarithmic equations. I have two properties to go about first. The first one is called the base exponent property. What that one says, if in an equation, if the bases are the same, the only way they could be the same is if the exponents are equal. Alright, so for example, 3 to the power x plus 1 equals 3 to the power 2. This one could have started off, it could start off as 3x plus 1 equals 9. But 9 is 3 squared. So you have to get it to the same basis first. Since the bases are the same, the only way they could be equal is if the exponents are equal. And then you solve for x. And there's that. The second one is the property of logarithmic equality. What this one says, if you have a logarithmic equation and the bases of the logs are the same, again, the only way that can be equal, if they're both log base a's, the only way that can be equal is if y equals x, if the operations equal each other. Alright, so, and also remember the change of base. Change of base. The change of base, if we have something other than E or 10, because remember your calculator has these two buttons. So anything else, this is log base 10, this is log base E. This is log base E. Anything else, we have to change the base. So we take the log of either one of those, and the operation goes on top, and the base goes on the bottom, but it's log base 10 in this case. Or it could have been the same thing with ln. Whatever's the operation goes here on top, whatever the base is goes on the bottom. Plus it's the proportion that's important, not really the numbers. Okay, let's look at some few examples here. Alright, the first one. 3x equals 20. I mean, because your first objective, try to get the same base. What that means is, if like the last example we had, so for this is 3, this is a 9, try to make them both the same base. If it's not possible, then take the ln or log base 10 or the log of one of the numbers. For example, So if not possible, then take the ln log base 10 or log of whatever one of the numbers that has the variable. So here, what I would do here, I would take log base 3 of both sides. Log base 3 of 20. On this side, since the base and the base are the same, this side equals x. This side equals log base 3 of 20. So that's what x equals. But we're not done because our final answers have to be in either log base 10 or log base e. So what we have to do is change our base formula. So log of 20 over log of 3. And that would be our final answer. Another example, let's look at one of we have a base number. 100 e to the power 0.08 t. This is an example in biology. In other words, like decay or rot of things. We're trying to get to t, because that's a variable. Remember, e is a number, 2.718281. So, for us to do, we have to get rid of the coefficient. So we have to divide both sides by 100. So that gives us e to the power 0.8t. Since that's a division by 1, just cancel the zeros. It equals 25. Now, we have to get rid of the base, because we're looking for this variable. So since that's base e, we take ln of both sides. So you know what that's going to do. On this side, ln and e are going to cancel, so we have 0.08t equals ln 25. And the good thing is ln is one of the numbers in our calculators. Divide both sides by 0.08. So we have ln 25 divided by 0.08. And put in your calculator, we get a number like 40.2. Alright, let's look at some more examples. What if we had this example? We have the bases, both sides are raised to a base. 4 to the power of t plus 3 equals 3 to the power negative x. Or, I'm sorry, t. We're solving for t. Since they're different bases, then it doesn't matter which of the two bases we pick, the logarithmics. Because it's easy, let's do log base 10. So log base 10 of 4t plus 3, log base 10 of 3 to the negative t. Now, whenever you have a base, you can't have exponents, so those exponents come out in front. So we have t plus 3 log base 10 of 4 equals negative t log base 10 of 3. Remember, now these are just solid numbers. Log base 10 of 3 actually exists, but we're solving for t. That t is by itself. This t is inside a parentheses, so we have to get rid of the parentheses. We distribute. So we have t log of 4 plus 3 log of 4 equals negative t log of 3. Alright? So we're trying to get all the variables to one side. Since we're solving for t, we want all the t's on one side, everything else that doesn't have a t on the other. So this one has to go there, and this one has to go there. So we subtract a 3 log 4 from both sides. We can't combine them because that's not the same. That's log base 4, there's log of 4, that's log of 3. So we can't combine those. So we have t log of 4 equals negative t log of 3 minus 3 log of 4. Now we've got to move this one since it has a t. So we add t log of 3 to both sides plus t log of 3. So we have t log of 4 plus t log of 3 equals negative 3 log of 4. Okay, we're trying to get t by itself. So what do? We have two terms. They both have a t in common, so I can factor out a t. So if I factor out the t, that's plus log 3. That's not supposed to be there. So I factor out the t, I have log of 4 plus log of 3 equals negative 3 log of 4. Get the t by itself, we have to get rid of this whole equation. So we divide by log of 4 plus log of 3. Both sides, so to divide both sides. Log of 3. Those cancel. So t is equal to negative 3 log of 4 over log of 4 plus log of 3. And that would equal, type in a calculator, it'll equal something around negative 1.6737. All right, let's look at another example. I know there's a lot of rules in this section. E to the x plus e to the negative x equals 6. Okay, these are already raised to as powers. Let's try another method here. So, since we can't combine these two, so let's try another one. We don't want to have negative exponents, so we have this negative exponent makes it go on the bottom. We have fractions and equal sign, so if we multiply the whole thing by e to the x, remember whenever you have fractions and an equal sign, you multiply it by the LCD, which is the LCD. So we have e to the x times e to the x, e to the x times 1 over e to the x equals e to the x times 6. So first find the LCD, we multiply, then we reduce, then we multiply again, get rid of the parentheses, and then we solve. E to the x times e to the x, same basis. Add the exponents. X plus x is 2x. This that cancels, we have just 1. Now we have 6 e to the x. Now we have an x on that side. So what we have to do is move it over there. And what we're going to notice when we do that, since we have 3 terms, it could be factorable. Remember, is it quadratic in form? How do we check that? Look at the middle exponent. If we take the middle exponent times by 2, does it equal the first? Yes. So it is quadratic in form. What that means is we can solve it either by factoring or quadratic equation. Remember, in quadratic, whenever you solve quadratics, you always solve for the middle term. So the quadratic formula. Negative b plus or minus square root b squared minus 4ac over 2a. In our equation, a is 1, b is negative 6, and c is 1. So let's just plug them in there. So it's negative of negative 6, square root of negative 6 squared, 4 times 1 times 1, that's AC, over 2 times 1. Negative makes it positive 6. Negative 6 squared is 36. 1 times 1 is 1, times 4 is minus 4, over 2. Plus or minus square root of 32 over 2. Let's see, can we factor 32 any further? That's 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2. So we can take out 2 pair. So it's 6 plus or minus 2 times 2 is 4, square root of 2. Alright, so as square root, you need a pair of numbers to factor it out, to come out. So there's a pair, it comes out as a 2. There's another pair, it comes out as 2. So 2 times 2 is 4. Alright, out of 6 and 4, what do they have in common? They both have a 2. So if I factor out a 2, I get this. That cancels. So my equation equals 3 plus or minus 2 square root of 2. So e to the power x equals 3 plus 2 square root of 2. E to the power x equals 3 minus 2 square root of 2. Okay, let's see how we solve those. We have e to the x equals 3 plus 2 square root of 2. E to the x equals 3 minus 2 square root of 2. Alright, so since we're trying to get the x, we have to take the ln of both sides. Ln of both sides. So ln and e are the same base, so it has x equals the ln of 3 plus 2 radical 2. Those cancel, so we have x equals the ln of 3 minus 2 radical 2. You type those in the calculators. I mean, if you can find this first, take the ln of it. What you're going to get are 1.76 and then negative 1.76. Because it's a quadratic equation. Apparently this one is centered at 0. Now let's look at solving logs. We're going to solve for logs. Let's say we had log base 3 of x equals negative 2. Remember our conversion. Log base a of x equals y converts to, a comes up here, so it's a to the y. The log drops off, equals x. So that's the conversion. So the 3 comes over here. The log drops off, so we have x equals 3 to the power negative 2. Negative exponent means it goes on the bottom. Drop the negative. So it's 1 over 9. The answer is 1 over 9. Let's look at another one. ln x. Oh, that should like. It could be ln x also in these examples, just whatever it is. X plus 3 equals 1. Okay, now to solve this one, what do we have to do? Since they're addition, and they're the same bases, we can combine these two. Remember this property. Whenever you're multiplying them, you could separate them by addition. So we have log x, this one, that's m, and this is n, equals 1. Remember, this is log, so it's log base 10. Let's distribute these. We get, well, no, we just leave it that right now, because what's going to happen next is we have to get rid of the log. So the 10 comes over here, the log drops off, x plus 3 equals 10 to the power 1, x squared plus 3x equals 10. It's quadratic, so we're going to make it equal to 0. 3x minus 10. And let's factor it out, if possible. X and x, that's a negative, so it's opposite signs. The bigger number gets a positive. What times what is 10? When I subtract them, I get 3. 5 times 2, 5 and 2. So the 5 gets the plus. So my answers are negative 5 and 2. So, but there's a problem here. You have to check your answers also. If I put a negative 5 there, can x be negative? Can x be negative? In other words, if I do the conversion of any number, can I have a negative number in there? Because this is a positive number. Can that equal whatever it's supposed to equal? Check it out. Use your calculator. Is one of the answers going to get dropped, or are both of them legitimate? Plug them in, each one. Take negative 5, plug in both of those. Work it out. Take a 2, put in both of those. Log of 2 plus log of 5 equal 1. All right? So check that out. Here's another example. Log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. All right. So what do you do here? Since it's subtraction, we have this property. So if we have m over n, that means since it's getting smaller, we have a subtraction. So since it's subtraction, I have a fraction. Whatever has a negative from it goes on the bottom. So it's log base 3 of 2x minus 1 minus 4 equals 2. My dog will start barking again. So now we have that equation. The base comes over here and pushes that up. So we have 2x minus 1 over x minus 4 equals 3 to the power 2. That equals 9. So we have 2x minus 1, x minus 4 equals 9. We get rid of the fraction, multiply both sides by the LCD. So those cancel. We have 2x minus 1 equals 9x minus 36. Solve for x. Move the smaller to the larger. Negative 1 equals 7x minus 36. Solve for x. Add 36 to both sides. So it's 35 equals 7x divided by 7. X equals 5. Yeah, let's try one more. And then we'll finish up the semester by doing chapter 6. We have ln of 4x plus 6 minus ln of x plus 5 equals ln x. Combine, that has a minus, so it's going to be a division. So we have ln 4x plus 6 over x plus 5 equals ln x. Since we have the same logs on both sides, these have to be equal. So we just drop the logs. Multiply by the common denominator. We got 4x plus 6 equals x squared plus 5x. It's quadratic, so it has to be equal to 0. Move these to the other side. So x squared, 5 minus 4 is 1, so, and the 5 is bigger, so it's positive x. Get rid of the 6. So 0 equals x squared plus x minus 6. Let's factor it out. X and x is negative, so it's opposite signs. What times what is 6? When you subtract them, you get 1. 3 and 2. And 3 gets the bigger number, so it's 3 here, 2 here. Solve them, you get x plus 3 equals 0. X minus 2 equals 0, so your answers are x equals negative 3 and x equals 2. And what we see here is because this number is negative, this x is negative 3. And if you plug it in here, it'll be positive. If you plug it in here, it'll be positive. But if you plug it in here, you can't take the ln of a negative number, because the domain of x's are all the positive x's. So this is your only solution. You always have to check your answers. All right, good luck everybody.